Okay, I'm going to walk you through our lecture on evidence-based practice. This is Dr. Eckhart. I'm going to go over some definitions and background about evidence-based practice and research, how to critique research, a little bit about PICO, how to do a systematic search of the literature, and a little bit about randomization and design. When you want to answer a research question, you always start with a clinical problem that you're interested in answering. And either you're going to answer it as a research question or it ends up being an evidence-based practice question. Well, if it's a research question, what happens is, let's say we want to know the best time to take the oxygen off the moms after we put it on for a baby's heart rate decelerates when mom's in labor. Okay, say mom's in labor and the baby's heart rate decelerates. And we say, okay, we put oxygen on the mom and we put her on her side, but what's the best time to take it off? So if there was good studies out there with strong evidence that people had done different studies that were in published journals, or you spoke to nurses at conferences who showed you their data and there was good evidence, you would take their findings and apply it to your population, and that would be evidence-based practice. But if there was no data out there and there were not good studies, what you would do then is do a research project to answer your question. You would have to go out and get your own data to answer the question of when is the best time to take the oxygen off the mom for good outcomes for both the baby and the mommy. So research is where you have to get your own evidence and data to answer that burning question that you want to answer, whereas with evidence-based practice, you use somebody else's information and apply it to your population of patients from their data and their strong evidence. Research utilization is just where you take evidence and apply it to a different setting. So, for example, if you wanted to generalize out, saying, well, okay, they say you have to be quiet in the ER, quiet in the NICU for adequate healing, which is how that started, the quiet healing in progress. And then that generalized out where we actually do it in emergency rooms now and on regular floors in an ICU. That's research utilization, where you take the findings of one research study and apply it to a different setting or population. In research, there are two types. There's quantitative research and there's qualitative research. Quantitative research has to do with numbers and data, and qualitative research has to do with language as the data. You talk to people and interview them. Quantitative research, we try and generalize out to other populations, whereas qualitative research, you're really just telling the story of one particular person. You don't need to generalize out to other populations. You're telling the story of one particular person and their experience with something. Quantitative researchers believe you can get a best voice for a group of people. Not a perfect voice, but a best voice, and that's usually reported as the average. But we also know it's not a perfect voice, so in quantitative research, besides reporting that average for that best voice for a process or a population that you sampled, they also report a little give and take around, a little variance, a little error in the measurement. So aside from reporting things like an average, they report the standard deviation around it if you took statistics, the variance, the margin of error, a confidence interval, whatever you want to call it. Quantitative researchers say you can't get a perfect voice, but you can get a best voice to represent something you're trying to see or look at, and that's the average reported in a number. And then you also report some variation in that measure, how imperfect it is, some measure of the not precision of the number, and that is quantitative research. Qualitative researchers say you absolutely cannot get a best voice for a group of people. You can't even get the best voice for one particular person. For example, when you're doing an interview, and think back yourself, when people speak to you or ask you questions, it depends upon who's asking the question, right? What time of day it is, what type of a day you had. Do they look like someone you love and trust, like one of your children, or does it look like someone you really don't like a nosy neighbor who's asking the questions? So qualitative researchers say you can't get the best voice for a group of people, you can't even get the best voice for a person. All you can do is say what happened or a story that they tell you, just report that data and see what people can pull out as common threads that might resonate with them. Most researchers do something called mixed or hybrid methodology, where we'll do a little quantitative, a little qualitative, and use the best of both worlds. Within qualitative research, the variables are the data are letters and language. We just spoke to that. And in quantitative, the two levels of data are discrete and continuous. With discrete data, you're either a yes or a no. You had an MI or you didn't. You have 0 children, 1 children, 2 children, 3 children. With continuous data, you had a 2.5-day length of stay. The baby weighed 8.5 pounds. The patient's temperature was 98.7. Continuous data, it makes sense and it's rational to put a decimal point and numbers after it, and you're still conveying something that's not silly. Whereas with discrete data types, it's silly to say I have 2.53 children. You can't count your spouse. So do you see the difference? Discrete, it's you're this or you're that. The decimal point you really can't do. It's not on that fine continuum. With continuous data, you can. And the reason why this is so important is this is what dictates how many people you need in a study in quantitative data, and also what type of analysis you would do to answer your research question. When you read a research article, these are the pieces of the article. The abstract, which is up top, because if you're going to be using evidence to answer a question, when you first want to answer it, you have to go look at the data that's out there in the research articles and see, is there sufficient evidence to answer your question as an evidence-based practice project? Or do you have to do your own research if there's gaps in that, if the research is really A, not out there at all, or B, not out there sufficiently to answer the question? So when you read a research article, whether it's in nursing or sociology or medicine, these are the parts of the article. The abstract is that full snapshot that says, this is why we're doing what we're doing, and what's been answered about it already, and what's still needed to be answered. These are the methods we use to answer the question. These are the results we got, and this is why it should be important to you. The abstract takes all of the other pieces, the introduction and background, the literature review, the methodology section, and then the discussion and findings and implications, and puts it all in a little 6-line, 5-line snapshot to tell you exactly what the article is about. There's a very nice article by a nurse named Arslanian, Arslanin, posted on the website or intranet that tells you exactly how to read a research article, also how to write one. When you do look at a study that's done from quantitative design, or you want to do a study, you want to make sure that your sample size is adequate. And we just spoke before about with discrete data and continuous data, there's different sample sizes. For discrete data, that yes, no, 1, 2, 3, 4 data, you need 90 people in each group to be able to see a difference if you're trying to compare like the effect of a drug or the effect of a teaching intervention. Whereas with the continuous data, which is where you can put a decimal point, like 3.2 days like this day, 8.5 pounds, 5.6 years old, that type of data, you'll need 30 observations in each sample to be able to have enough, to have adequate power, to have some good statistical data that you can actually answer your question with. The most important thing with the sample, though, is to make sure that the sample that you get actually adequately represents the population you're interested in. For example, if I wanted to know the satisfaction of all the nurses at Good Samaritan Hospital, if all I did was sample or get a measure of satisfaction from the nurses on the day shift in one unit, that sample really wouldn't represent my population of interest. If I only wanted to know the happiness of the nurses on the day shift in that unit, that would be a fine sample. But if I wanted to know about all the nurses in Good Sam, that would not be a good sample. The biggest thing to take away with sampling, besides the statistical piece, which you don't have to have a good understanding of research at this point, is are the people we're looking at, or are the processes we're looking at, or are the blood cells we're looking at on a slide, are they representative of everything we're interested in? Because if they're not, it's not a good sample and it's not going to answer your question. You also want to make sure that the survey you're using or the blood pressure cuff you're using to get blood pressure measurements for research, or whatever instrument you're using, that it's reliable, which means that if I use the blood pressure cuff and you use the blood pressure cuff and your other nurse on your unit use a blood pressure cuff, we'd all get about the same readings. If it was at the exact same point in time with the patient with the exact same measure. Or if I was measuring someone's weight, a baby's weight after birth, we'd all get about the same weight. I wouldn't get that the baby weighed 5 pounds, you got the baby weighed 15 pounds. That wouldn't be reliable. You also want the data to be accurate and valid, meaning as close to the true measure as possible. Going back to the baby example, even if we all got the baby's weight as 5 pounds, and that would be very reliable, if the baby truly weighed in actuality 7 pounds, it would not be valid at all. So you want to get close to the true measure, which is validity, and that everyone who's measuring it gets the same measure, about, not exact, doesn't have to be exact, there's always a little error in measurement, and that's reliability. Okay, the biggest takeaway is here about sampling. In 1936, there was a literary digest place, it'd be like Gallup now. Gallup polls, they polled nearly 2.5 million voters. Remember I told you only need 90 people on this type of data to get an adequate sample size? And they asked 2.5 million people, they sampled these people saying, who are you going to vote for president? And despite this huge sample size, they were off by 19 percentage points. They got it totally wrong. And how they got their data was they got from the list of all the automobile owners and a list of all the telephone owners in 1936, and called these people up, used a random number generator, had great statisticians who did it because they wanted to randomly select people. It means everyone has an equal chance of being chosen, so there was no bias in who they were selecting, so they thought. And they would call people and say, hey, who are you going to vote for president? Oh, who are you voting for president? And they were off by 19 percentage points. So I'm going to give you a minute to think where this went wrong. Just read the slide for a moment. Remember, it's 1936. They used lists of people who own phones and who own cars. Okay. They tried to avoid bias by doing a random sampling, so they were not going to just get a certain subportion of the population, but in actuality, where they drew their information from, automobile owners, telephone owners, in 1936 did not represent the whole population. In 1936, people with money had telephones and automobiles. If you didn't have a lot of money, if your socioeconomic status was lower, you would not have been sampled. Had the researchers just wanted to know how rich people were going to vote, or people with money, back in 1936 for president, they probably had a perfect sample. But that's not who they wanted to know. They wanted to know how everybody who was going to vote was actually going to vote. They were trying to predict the winner of the president, and everyone gets to vote, whether you have money or not. And that was the problem. So the big takeaway with that is making sure that the people that you want to answer or get a question from or represent in your sample truly represent your population. Okay, we already looked at this slide, reliability and validity. Reliable means that is repeatable. We can all get the same measure again and again. And validity means close to the true measure. The baby, 7 pounds, and we all get 7 pounds. Okay, this is the end of the first podcast. There's going to be one more podcast for today. I've spent so much